All right, so the recording has started. So let's dive into today's lecture. So we have been discussing about decision tree classifier and how a decision tree works. Now, one of the things we have seen that in a decision tree, when we have a data set, we start splitting the data set using attributes. Okay, and we were discussing in the last class what attribute should we use to in order to split, and we have seen that there are many ways of splitting. One thing that we've seen in the last class is using the Gini index to actually do the splitting. Mone ache naki na?
Yes, sir.
Okay.
Yes, sir.
There are other measures of impurity that we have, like entropy bole ekta measure ache. Okay, we can use the idea of entropy as well as to split. So we can, what is entropy? Entropy is another measure of impurity. So we can use entropy to measure the impurity. Okay, so the idea of entropy is heavily used in physics. If you have learned about the second law of thermodynamics and stuff like that, you may have heard of entropy, right, Nakina? Clear? But the concept of entropy actually came from information theory. Okay, right, the Shannon's information theory. Okay, so without going much technical details on how this how this formula has been derived, we'll just use the formula. We'll see the formula and we'll see how does this formula give you a measure of impurity. Okay, and then we're going to use this formula to actually do the splitting. Okay, so entropy is given by this formula. So this is the formula that we use to measure, to quantify, to measure entropy. Okay, all right. So entropy is a measure of impurity as well. Like a Gini index is a measure of impurity, we have entropy as well as a measure of impurity. Okay, now let's have a look here. So the formula for entropy is given by as sigma. So for all the classes from I equals to 0 to C minus 1, that means for all the classes, okay, you multiply the probability of the occurrence of the class multiplied by the log of the probability of the occurrence of the class, log of base 2. And when you sum that up, after that you put a minus sign before that, because log of a probability, any probability is what? Any probability of a class should be always smaller than 1, greater than 2, or in the worst case equal to 0 and equal to 1 here, right? Okay, that turns out if your probability is smaller than 1, if you take a log of that, log of a value which is smaller than 1 is always negative, right? So these product will be a negative value. So you sum them up, then you multiply with a minus 1 in order to make that negative as positive. So we have an entropy which is a positive value. Is that okay, Nakina? Clear? Okay, so that's the formula
Yes,
that we're going to use to measure the entropy. Now let's just see how does this formula help you to measure entropy. Okay, now here we are. So I'm going to give you some situation here. Class 1 and class 2. Let's say there are 0 instances of class 1 and 6 instances of class 2. In another situation, we have 6 instances altogether, 1 instance belonging to class 1 and the 5 instances belonging to class 2. And there is a third scenario in which we again have altogether 6 instances, but 2 instances in class 1 and 4 instances class 2. Okay, without doing any calculation, can you tell me which one is the most pure one and which one is the most impure one?
Sir, first on
First
most
one is
pure.
what? Most what? Pure or impure?
Pure, sir.
Pure. So this
Most-
is the most pure one because everything belongs to class 2. There is nothing from class 1 here, right, Nakina? Yes?
Yes, sir.
Right. And then the second most pure one is this one. There's a little bit of impurity because there is 1 instance in class 1. But this is more impure or less pure because there are 2 instances from class 1 and 4 instances from class 2. Am I correct, Nakina? Yes?
Yes, sir.
Okay. Now, if we would like to find out entropy for each of these cases, what happens? Now, let's look at for this one. For this one, there's a total of 6 instances, 0 in class 1, 6 in class 2. So there is a total of 6 instances. So what's the probability that an instance belongs to class 1? What's the probability that an instance belongs to class 1? 0 divided by So
6.
0 by 6, which is 0. And what's the probability that an instance belongs to class 2? There are 6 instances out of 6
1.
instances. So 6 by 6, which is 1. Is that clear, Nakina?
Yes,
Yeah?
sir.
Now, if that's okay, how do you find out the entropy? The entropy is given by this formula. So what I'm going to do is this. I'm just going to write it here. Entropy equals to minus, there is a minus, and then I'm going to sum up these products. So I'm going to multiply by the probability with its log. So first one, for the first class, what's the probability? Probability is 0 times what's the log? Log of base 2, 0. Clear, Nakina? Yes, Nakina? Okay.
Yes.
And for the second class, so plus, because we're summing it up, for the second class, the probability is 1. So it's 1 times log of base 2 of 1. Correct, Nakina? Is that clear?
Yes, sir.
Yes,
So
sir.
you simply, for each of the classes, you multiply the probability with its log, okay, and you add up all these values, and then you put a negative sign before that. That's basically the entropy, okay? And if you do that, the entropy comes out to be what? 0. Is that okay, Nakina?
Yes, sir.
Yes? Because here, simple, 0 times anything is 0, plus it turns out to be log 1 of base 2 is 0, so 0 times anything is 0, so 0 plus 0 is 0, minus 0 is the same as 0. Is that okay, Nakina?
Yes, sir.
Yes? Okay. What about for the second case? In the second situation, what is the probability that an instance belongs to class 1? The probability that an instance belongs to class 1 would be 1 out of 6. Is that correct, Nakina?
Yes, sir.
And the probability that an instance belongs to class 2 is 5 out of 6. Okay, so the probability that an instance belongs to class 1 is 1 over 6, and the probability that an instance belongs to class 2 is 5 out of 6. Is that okay?
Yes, sir.
Now, if that's
Okay,
all
sir.
right, so the entropy is very simple. So what you do is you just write it this way. Entropy is you put a minus sign before that, and then sum it up, multiply the probability with its log of that. So probability is 1 by 6. So the probability was 1 by 6 times log of base 2 of 1 by 6. Correct? Plus, for the second one, the probability is 5 by 6. So 5 by 6 multiplied by log of base 2 of 5 by 6. And you're done. Clear, Nakina? Is that okay?
Yes, sir.
Of course,
Yes,
don't get confused. Sir, keep plus this chicken, they can minus this, because if you multiply, minus of this is minus that, minus plus is that minus of that. It's the same thing, okay? And if you compute that, that probability comes out to be 0.65. Is that okay, Nakina? Yes?
Yes, sir. Okay.
Everyone okay so far?
Yes, sir.
Yes,
Hello?
sir.
বাকিরা সবাই শুনছি ঠিকমতো? Yeah?
Yes, sir.
You guys need to participate, okay? So
Yes.
similarly, for the third situation, I can also find out the entropy in the same way, and I get to be 0.92. So what can you see? যেটা যত পিওর হচ্ছে তার এন্ট্রপি কি?
বেশি
ছোট
হচ্ছে।
না
তত
বড়?
কম, তত কম।
তত কম। তার মানে যেটা যত ইমপিওর সেটার এন্ট্রপি কি হবে?
বেশি।
বেশি। So can I therefore say that actually really is why I'm saying that entropy is a measure of impurity. The higher the entropy is, the more is the impurity. The lower the entropy is, the lower is the impurity, and the higher is the purity of that. Is that okay, Nakina?
Yes, sir.
Yeah. So that's why we can use entropy, the concept of entropy, as a measure of impurity as well. Is that okay to everybody? Yep. কারো কোনো questions আছে so far?
Yes, sir.
ঠিক আছে না নাকি না? Yeah.
Yes.
Okay. So once we have that, so we can use the idea of entropy to actually find out, what's the let's imagine we can use the entropy to find out which attribute shall I use in order to split. Now remember, when we were discussing Gini impurity or Gini index, okay, we used the concept of gain, right? There was a concept that we used called gain. Yes or
Yes.
no?
Yes, sir.
Gain was what? You find the Gini before you split, and you find the weighted Gini after you split. And the gain is the Gini value before you split minus the Gini value after you split, right? Mone ache naki na? Yes?
Yes, sir.
Yes, sir.
So this is what we did, right? So we had to find out, what's the Gini value before splitting. This is what we did over here. And then we found out what's the Gini value after we split. But Gini value after we split is সমস্যা হচ্ছে split করলে দুইটা নোড হচ্ছে, একটা নোড এদিকে একটা নোড এদিকে, if we are doing binary splits, right? নাকি না? Okay, so I can find out the Gini value for this node and for this node. So then once we find the Gini value for this one and this one, we need to find out the weighted Gini of these entire after the splitting, right? নাকি না? Clear? So the gain would be then the Gini value before splitting minus the weighted Gini value after splitting. Am I correct, Nakina? Yes?
Yes, sir.
Correct.
Yes,
This
sir.
is what we did in the last class. That's the same thing we're going to do with the, entropy as well. So how do you find which one is the best attribute? So what I do is we find the entropy of a node before splitting, okay? Before the split, let's find out the entropy. And let's find out the entropy after the split. But again, what will happen is, because after splitting, if we're doing binary split, we will have two nodes, right? The left child and the right child, okay? So if we have two children, okay, the left child and the right child, the left child will have one entropy, the right child will have another entropy maybe, or they might have same entropy as well, depends, okay? But they can have different entropy. So which entropy to use? So you have to find out the weighted entropy. So that's why over here, what we do is this is the weighted entropy after we split, okay? So I'll write it down over here. This is the weighted entropy after the split, okay? So this is the weighted entropy after splitting, okay? After we split with a particular attribute, right, Nakina? Yes, is it okay? And this is the weighted entropy before we split. So that's why we wrote this is the entropy of the parent, okay? All right, so this is the entropy before the splitting is done, okay? Before splitting. So what would be the gain then? The gain would be the entropy before splitting minus the entropy after splitting, because we are assuming in this case that splitting will make it more pure. So if the splitting makes it more pure, its entropy will go down. Am I right, Nakina? Clear? Yes?
Yes, sir.
So the weighted entropy after splitting should be ideally smaller than the entropy before splitting. Am I correct, Nakina?
Yes.
Yes?
Yes, sir.
Right. So it becomes more pure. So the gain would be the difference between these two. So the gain would be the entropy before splitting minus the weighted entropy after splitting, just like what we have done in case of the Gini index. For the Gini index, well, we find the gain by subtracting the weighted Gini after splitting from the Gini before splitting, right? That's exactly what we have done over here as well. We find the entropy of the parent class or entropy before splitting, and then minus, we find that the weighted entropy after splitting, okay? And the difference between them is what is the gain. Is that okay, Nakina? Is that clear, Nakina?
Yes, sir.
Yes?
Yes, sir.
Okay. This gain that we find using entropy as a measure of impurity is sometimes what is also known as the information gain. That's called the information gain. Why is it called information gain? I don't want to go into the details of that, but I will say this much a little bit, that because the concept of this entropy has been derived from information theory, and that's why we call it information gain. But there is a basis from information theory, but let's not go into this one. Is that okay? So this gain that we're getting, if you are using the entropy as a measure of impurity, is what is called the information gain. Is that okay, Nakina? Clear?
Yes, sir.
Okay. Now, imagine we have got a data set and we have got a number of attributes. So for each attribute, we find out what's the information gain. Once we figure this out, which is the attribute that we should select in order to, split? কোনটাকে use করব? The one with the high gain or low gain?
The lowest impurity.
Sorry?
Sir, the gain এর score বেশি।
The one with the high gain or the one with the low gain?
High gain.
High gain।
High gain. Okay, because the one with the high gain মানে কি, gain যদি যত বড় হবে তার মানে কি এই ডিফারেন্সটা তত কি বড় হবে না ছোট হবে?
তত বড়।
বড় হবে।
তাহলে এই দুটো ডিফারেন্স কি হবে, বড় না ছোট?
বড়।
বড়। ডিফারেন্স বড় হলে এইটার ভ্যালু কি হবে, the weighted entropy after splitting বড় না ছোট?
ছোট হবে।
The weighted entropy ছোট হওয়া মানে কি, তার মানে হচ্ছে it's more pure, it's more pure than with other attributes, তাই না নাকি না? Clear?
Yes, sir.
Yes, sir.
That's exactly our strategy. We wanted to make as pure as possible, ঠিক আছে, right নাকি না? Yes, so that is the attribute that we would like to look into, because this is the attribute that would make your this is the attribute with which if you split, will split it more purely. Maybe there's still some impurity and you may need to split further, but at least if you're using this information gain, okay, in order to split, okay, and you look at the higher information gain, that's going to actually split it more purely. Is that right nakina? Clear nakina?
Yes.
Yes, sir.
কি হবে যদি আমি if I do not choose the attribute with a high information gain, I choose করলাম একটা attribute with a low information gain, তাহলে কি হবে? And I keep on splitting it until I get pure. What will happen? Will the decision tree be longer or will the decision tree have the same height? What do you think? Longer হবে, কারণ it will take more and more, splitting, ঠিক আছে, in order to actually get in its purest form, right? Clear? Okay, so
yes,
the
sir.
decision tree will be longer. But why is that not desirable? That's something we're going to talk about it later. Okay, all right, okay. But so far, is it clear, Nakina? So far?
Yes, sir.
Yeah. All right, so yes, that's what we're gonna do, right? So this is basically our idea. But there is a particular problem that we have with this, with the idea of entropy. Okay, and what is the problem? Look at here. Imagine we have got gender as an attribute, and I use the gender to split. So if I use the gender to split, let's say if the gender is yes, means let's imagine male, and if the gender is female, you go on that side. Okay, so when the gender is male, there are altogether 10 instances on the left, and there are altogether 10 instances on the right. Clear, Nakina? Is that okay? But if I split it using card type, then it could be family, sports, and luxury. For the family, there are how many instances on the left? 4. How many instances with sports?
8.
8.
And how many instances on the right?
8 also.
Also 8. Okay. Right. And if I do for customer ID, let's imagine we are splitting using customer ID as well. So we could have customer 1, 2, 3 up to 10, then up to 11, then up to 20. Okay? So how many are there in this one? 1. 1. All of them would have only one member over here. Now, if I'm using, entropy to split, তোমার কি মনে হয় কোনটাকে সে পিক করবে out of these 3? Gender, card type, নাকি customer ID? Which one do you think would have a higher information gain?
So customer ID?
Customer ID. These are actually becoming very pure, right, Nakina?
Yes, sir.
Right. But তাহলে আমি যদি entropy use করে যদি, if I want to find out a particular attribute, it probably will favor customer ID, right? But is customer ID, yeah, and that's what's written over here. Customer ID has the highest information gain because the entropy for all the children is 0. Entropy is 0. Why the entropy is 0? Because it's pure. Look at over here. It's pure here, right, Nakina? What was the entropy? 0. So entropy was 0 means that it will have the highest information gain, right? Nakina. Okay, তাহলে it would select customer ID. But is customer ID a suitable feature to be split by?
No, sir.
No.
No,
Why
sir.
not? Why not? Why is customer ID not a suitable feature?
So the branching factor of the precision tree will increase.
Say that again, please.
So branching factor increase করবে স্যার অনেক বেশি আইটার আমার একটা সলিউশনের
Branching
জন্য
factor থেকে আরেকটা ব্যাপার হচ্ছে, the problem is really, if you have a test, instance, let's say একটা নতুন রেকর্ড আসছে and একটা নতুন instance আসছে, right? This is a new instance and you want to classify this instance, right? So for example, this is a new instance and these are different attribute values and so on. You want to classify certain thing over here. Now for this new instance, if I use this one card type, for example, I can check, acha, ei instances in a card type ta ki chilo, family na sports na luxury. I can look at it and I can branch out that way. Okay, but for the same new instance, can I check for customer ID? No, because none of them would be valid because this is a new instance and has a different customer ID, right, Nakina? Clear?
Yes, sir.
Yes, sir.
Yeah, and so you cannot branch even because you don't have any these customer IDs 1 to 20. Maybe this is a customer ID of 21. Okay, and so none of them will actually match, so you don't know which way to go. Is this clear, Nakina? Yes.
Yes, sir.
So if you're using entropy to do that, it will favor customer ID, but that is not something useful. Okay? And yes, you have said it rightly that if you have a particular attribute for which there's a lot of branching over here, the branching is very high, then that might be a problem. Okay? And it turns out that entropy, in case of your entropy, it will favor that particular feature with a high branching factor, and that sometimes may not be very useful. Okay, so that's a problem with entropy. Clear, Nakina? Is that okay? Yeah, got it?
Yes, sir.
And how do we get rid of this problem? The way we can get rid of this problem is, instead of using just information gain, instead of using this idea of information gain, we can use something called a gain ratio. You can use gain ratio to figure out, okay, which attribute to use. So instead of using information gain, we can use something called a gain ratio. Now, what's a gain ratio? Gain ratio is given by gain split divided by split info. Now, what's a gain split? Gain split is the information gain. This is the gain split. That's the information gain. Okay. All right. So that's there. So this is the information gain. But you divide the information gain by something called split info. And split info is given by the formula this. Okay. All right. Now, that's just a formula. I'll just tell you what does split info say. Split info is, in split info, you multiply the number of instances in that class by the overall instances of the parent and multiplied by the log of, the ratio of, the number of instances in that class by the number of instances in the parent. Okay. If you do that, it turns out that higher the branching factor is, যতগুলো branches থাকবে, তত split info size বেশি হবে। ঠিক আছে? So if your branching factor is larger, if there are many branches, okay, branches means these branches, okay. If this has a high branching factor, it turns out, if it has a high branching factor, okay, then the value of the split info will also be higher. ঠিক আছে? So যদি তোমার ব্রাঞ্চিং ফ্যাক্টর যদি হাই হয় তাহলে স্প্লিট ইনফো ভ্যালু কি হবে? এখানে হাই না লো? High. Now think about it. If the split info is high, so what will happen to the gain ratio?
স্যার কম হবে।
Low. Exactly. So instead of information gain, you're using the gain ratio to decide which one to use. So এখানে কি হবে? If you're using this gain ratio, it is taking this into consideration. If something has a high branching factor, এটাকে penalize করা হচ্ছে। ঠিক আছে? Because you're dividing by the split info, it's penalizing the information gain. Is that clear? Okay. So it adjusts the information gain by the entropy. So it penalizes that. Clear? Is that okay, Nakina? That's how it ensures that if something like that comes up with a very high branching factor, it's not, it's not favored in that way. Because it's something that should be penalized, but because that's something that may not be ideal. Clear, Nakina? Okay. So in that sense, sometimes we use the gain ratio instead of the information gain. Is that clear?
Yes, sir.
Yes,
So
sir.
that's the way we can deal with this problem. Is that okay? All right. So higher entropy partitioning is penalized. That's what is written over here. Higher entropy partitioning is penalized. Is that okay? Yes?
Yes, sir.
Yes, sir.
Yeah. So that's basically the idea between idea of what do you call this one? The information gain and gain ratio. Okay. All right. Okay. So I hope this is clear, Nakina. Motamoti clear, Nakina. Is that okay? All right.
Yes.
Okay. Good. Now you see over here. Well, let's look at over here. Now in this case, you have got, if you are splitting using the card type, there are three branches. One is by the family type, by the sports, and by the luxury. But if I do it this way, I have, sports and luxury একদিকে আনলাম, family একদিকে আনলাম, আবার এখানে sports একদিকে আনলাম, family luxury একদিকে. You use the same attribute, but you use it different way. Can you see that over here? Okay. The split info value is 1.52 for this one, 0.72 here, 0.97 here. Look at here. It has split info value high or low?
High.
High compared to the others. It's just because, but it's the same attribute that we're using, which is the card type, but the split info value would be higher. It's just because we have more number of branches over here. Is it clear, Nakina? Yes.
Yes, sir.
Okay. So that's what it shows, that if you have a high branching factor, okay, the split info will be higher, which will eventually lower down or penalize the gain ratio. Okay, penalize the information gain. So we have a lower gain ratio. Is that okay, Nakina? Clear?
Yes, sir.
Okay. Right. Now there is a third way we can measure impurity, which is something called classification error, and which is given by this formula called error is equal to 1 minus maximum probability, okay, that we have. Okay. All right. So how do you use this one? Okay, this is the third way to measure impurity. So how many ways of measuring impurity is something we have seen?
Sir, দুই ভাবে।
তিন ধরনের.
Thank
There
you.
are three measures of impurity we have seen. First is Gini. We can use the Gini index to measure impurity. Second, we have seen the entropy. And third, now we are seeing the classification error. ঠিক আছে? Is that clear?
Yes, sir.
So there are three measures of impurity. Okay. So Gini index, entropy, and now we have something called classification error. Now let's look at this idea of classification error over here. It's given by the formula 1 minus maximum probability. Okay, let's see here. Let's see this situation. Class 1, there are 0 instances of in class 1 and 6 instances in class 2. Now, what would be the error? Okay, so let's find out first of all probability. How many instances, what is the probability that an instance belongs to class 1? So now there are 0 instances in class 1. In overall, 6 instances altogether, right? So 0 out of 6. So the probability that an instance belongs to class 1 is 0. Am I correct, Nakina? Yes?
Yes, sir.
Yes. What is the probability that an instance belongs to class 2? Okay. Now there are 6 instances in class 2. Out of overall 6 instances, so the probability that an instance belongs to class 2 is 6 over 6, which is 1, correct?
Yes, sir.
Yeah,
Yes, sir.
that should be okay, right? So now if you use the formula, error is 1 minus maximum of the probability of the classes that we have. So 1 minus maximum, so 1 probability is 0 and 1. So out of 0 and 1, which one is the maximum?
Once.
1. Out of 0 and 1, 1 is maximum. So 1 minus 1. So the error is 0. Is that okay, Nakina? Clear?
Yes, sir.
Okay. So I think you get the idea, right? So what about for the second class? For the second class, if I find out the probability for class 1, well, again, you see over here, there are altogether 6 instances, 1 belonging to class 1 and 5 belonging to class 2. So there are altogether 6 instances. So what's the probability that an instance belongs to class 1? So there's 1 out of 6. So 1 out of 6. And what's the probability that an instance belongs to class 2? That should be 5 out of 6. Is that okay, Nakina? Yeah?
Yes, sir. Okay.
So what is the error? Error is the 1 minus maximum of these two probabilities. A duta probability with the maximum kunda 1 by 6 or 5 by 6.
5 by 6.
is the maximum. So 1 minus 5 by 6 is the answer is 1 by 6. Correct?
Yeah.
ঠিক আছে?
Yes, sir.
Okay. What about for the third case? Third case, well, probability, again, there are 6 instances altogether. So probability that an instance belongs to class 1 is 2 out of 6, and the probability that an instance belongs to class 2 is 4 out of 6. So the error would be 1 minus maximum of these two probabilities, 2 over 6 and 4 over 6. Out of 2 over 6 and 4 over 6, 4 over 6 is maximum. So 1 minus 4 over 6, which is 1/3. Okay. Now look at this one again. For these 3 situations, situation 1, situation 2, and situation 3, which one is the most pure one?
Sir, on
Situation 1 is pure, right? So I give the 3 ticks to show the strength of pureness. This is one is less pure than the first one, so I'll give it 2 ticks, and this is even less pure, so I'll give it 1 tick. Correct, Nakina? And now if you see over here, the one that is more pure has a very small error value, right? This is less pure, it has a slightly more error value, and this is even less pure, and this has a slightly more error value, right? 1/3 is higher than 1/6, right? Because if you multiply 2 in the numerator and the denominator, this is 2 by 6. So out of 1 by 6 and 2 by 6, 2 by 6 is larger. That means the higher the purity is, the lower is the what?
error.
Error, right? So the higher the purity is, the lower is the error. That means the higher the impurity is, the higher is the error. Therefore, this classification error can also be used as a measure of entropy. Is that making sense, Nakina?
Yeah, yes, sir.
Yeah, is that clear to everybody that I can use classification error as a measure of entropy as well?
Yes, sir.
Shall I take it? Okay. So now we have seen that there are 3 criterions that we can use in order to, split. There are 3 splitting criterions that we can use, okay? Or there are basically 3 ways we can actually, measure the degree of impurity. One is using the Gini index. One is using the entropy. The other one is using the idea of classification error. Is that okay, Nakina? Does it make sense?
Yes, sir.
Okay. Now, there's a very interesting thing. They have a characteristic curve. So if you look at for a 2-class problem, 2-class problem is binary classification, binary classes. So binary classes means there is class 1 and class 2, things like that. Okay. No more than 2 classes. Now, if you look at this carefully, entropy and Gini, they have a very nice concave shaped curve. If you see it here, so it goes up here and then go down there this way. This one go up here, hit it at the peak here, and then go down. It's a very nice concave shaped curve. So they have a characteristic concave shaped curve. Concave shaped curve. Okay. So both your entropy and Gini has the highest concave shaped curve. Right, Nakina? Clear? Okay. So in this one, what do we plot on the y-axis? What did we plot on the y-axis? What did we plot here on the y-axis? That is the measure of impurity. Measure of impurity. How do we measure the impurity? Well, if you are using the formula for entropy, so you use the formula for entropy to measure. If you are using the Gini, then you use the formula for the Gini to measure. And if you're using mixed classification error, use the formula for the mixed classification error to measure the error. Is that okay, Nakina? Clear?
Yes, sir.
And what do we plot on the x-axis?
Probability.
The probability. Now, look at over here. If the probability is 0.5, 0.5 probability মানে কি? It's a binary class, তাই না? Yes?
Yes.
Okay. Binary class মানে হচ্ছে class 1 আছে আর class 2 আছে. If I say the probability is 0.5, that means the probability that an instance belongs to class 1 is 0.5, and therefore the probability that an instance belongs to class 2 is also 0.5, right? Now, এরকম যদি equal amount of instances থাকে in class 1 and class 2, so it's equally split. So এটা কি? Is it the highest impurity or lowest impurity? What do you think?
So neither.
Highest impurity.
Highest impurity, and that is the reason you see over here that exactly at 0.5 you have the highest value of the impurity for all the cases, for the Gini, for the misclassification error, as well as for the entropy, right? Is that okay, Nakina?
Yes.
Yes, sir.
ঠিক আছে? Is that clear?
Yes, sir.
Yes?
Yes, sir.
Hello?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. And look at one more interesting thing. As you go more towards the right, this is becoming more what? Pure or more less pure?
Pure.
Pure.
It's becoming more pure, right? Okay. What about if you're going from the middle, if you're going more towards the left, what happens? Is it becoming more pure or less impure? Less pure.
Pure.
Again,
More
it's
pure.
becoming more pure, right? Is that okay, Nakina?
Yes, sir.
Yes. Okay. Right. As you are going towards the middle, it's getting more and more impure. Is
Yeah.
that okay? Right, Nakina? That's why if you go more towards the left, you see your Gini value or the entropy value or the misclassification value, error value, they are all decreasing because it's getting more pure. যত pure হবে তত তাতে impurity indexটা কমতে থাকবে. The same thing that you see over on that side, this is also decreasing here and here. Is that okay, Nakina?
Yes, sir.
Is that a good idea? Is this clear, Nakina? Right?
Sir.
And as you're going more towards the probability of 0.5, as you're approaching that, it's going to increase and will be maximum at the probability of 0.5. When you have a probability of 0.5, that's when you have the maximum impurity. Is that clear?
Yes,
স্যার
sir.
0.5 এ বেশি হওয়ার কারণটা কি স্যার? আমরা নেটের জন্য শুনতে পারি না স্যার, আবার একটু বলবেন?
So 0.5, it is the two class problems, right? Two class problems means there are two classes here, class 1 and class 2. So আমি ধরো class 1 এর probability শুধু measure করছি, তার মানে 0.5 যদি class 1 এর probability হয়, what is the probability that an instance belong to class 2? Also 0.5. Is that okay?
Yes, sir.
Because overall probability is 1.
Yes, sir.
না তুমি আমাকে বলো probability half half থাকে, তার মানে 50% instances are in class 1 and 50% instances are in class 2.
More
Is it
impurity,
more-
sir.
Is it more pure or less pure? Yes? Is it more pure or less pure?
স্যার less pure আর কি, more impurity আর
Less
কি।
pure or more impure, right? Nakina, clear?
Yes, sir. Yes, sir. Clear.
Yes, that's what I say. What I'm saying here, right? It should be more impure. That's what we are saying here. So if it is more impure, the higher the impurity is, the more is the entropy or Gini values. Then Nakina, that's when they're gonna maximum.
Yes, sir. Clear, sir.
Make sense? Right. Okay. Very good. So we understand the characteristic curves as well. Okay. It turns out, and I'll tell you right now, that in order to have a nice measure of impurity, we want it to be concave shape. এই তিনটার মধ্যে কোনটা concave shape না?
Misclassification
Classification
error.
Misclassification error. And that's why typically we do not use the misclassification error as a practical way of measuring impurity. So in order to measure impurity nicely in a practical way, we typically use either entropy or Gini index. We do not use misclassification error. ঠিক আছে? All right. But let me try to give an example. That why do we not want to measure? Why we do not want to use the misclassification error as a measure of impurity. Okay, I'm going to show you this example here. let's see over here. Now let's imagine we have how many before the splitting, how many instances are there? So for the parent node, so that means we have not yet split. Okay, before splitting, how many instances do we have over here?
10.
10 instances. So there are altogether 10 instances. Okay, 7 instances belongs to class 1 and 3 instances belong to class 2. Is that okay, Nakina?
Yes, sir.
Right, good. Acha. Now if we want to find out the Gini, remember Gini কিভাবে বের করি জানি? মনে আছে formula?
Yes, sir.
মনে আছে, right? আচ্ছা. If you find out the Gini comes out to be something like 0.4. Is that okay, Nakina? So this Gini value of 0.42 is before splitting or after splitting?
So before splitting.
Before splitting. Now let's say I split it using the attribute A, whatever the attribute A may be, doesn't matter. Now if we split using the attribute A, imagine we get two child nodes over here. Okay, the left child is node n1 and the right child is the node n2. Okay, so now that's what is showing over here in this example. Forget this one. Let's look at this one. Let's look at this case. Let's say in this case, node n1, okay, will have 3 instances that belongs to class 1 and 0 instance that belongs to class 2. And node 2, which is this one, will have 4 instances in class 1 and 3 instances in class 2. Now, okay, if we find that the weighted Gini is how much? 0.342. Is that okay, Nakina? Clear?
Yes, sir. Yes, sir.
Yes? Now clear
Yes,
to
sir.
the bottom? I can help you out. Is that okay?
Yes, sir.
Yes, sir.
Okay, we can find out the weighted Gini, right? Nakina?
Yeah.
Okay. Now let's look at another situation. This is another situation. এখানে node n1 এ আসছে altogether 4 instances, 3 belonging to class 1, 1 belonging to class 2. And node n2 তে আসছে 6 instances, 4 belonging to class 1, 2 belonging to class 2. Correct Nakina? Okay? Right?
Yes, sir.
ঠিক আছে? Okay. And if we measure the weighted Gini should be 0.416. Is that okay, Nakina?
Okay,
Yes,
sir.
sir.
Right. So is it clear that the weighted Gini, okay, is different from the parent class, right, Nakina? So we have different Gini values for different situations. Is that okay, Nakina? Yes?
Yes, sir. Yes, sir.
And that's what I should ideally find out. Then, Nakina? Yes?
Yes, sir.
Okay. But instead of Gini, if I use the misclassification error to figure it out, now you would see that the misclassification error would be now, okay, let's see. Let's say without, let's not worry about the Gini. Let's think about finding out the misclassification error. Let's find out what's the misclassification error for the parent class. What's the formula for the misclassification error? Does anybody remember?
1 minus
1 minus maximum of the two probabilities. Okay.
Yeah.
What is the probability that an instance belongs to class 1?
7 by
7 by
10.
10.
7 by 10. Very good. And what is the probability that an instance belongs to class 2?
3
3 by
by
10.
3 by 10. So what's the maximum of 7 by 10 and 3 by 10? Which one is the maximum?
7 by 10.
7 by 10. So what is 1 minus 7 by 10?
3 by 10.
3 by 10, which is 0.3. So you get the error to be 0.3 for the parent class. Is that okay, Nakina? Yes?
Yes.
Yes, sir.
So now for this case, for this situation, এই সিচুয়েশনটা এই নোডের জন্য না, এই সিচুয়েশনটা দুইটা নোডের জন্য, n1 এর জন্য n2 এর জন্য দুইটাতেই দেওয়া আছে। We want to find out the weighted error. Let's find out the weighted error. দেখি একটু ভালো করে দেখেন। So এই কেসের জন্য for the second situation, okay, so let's look at the second situation. First situation তো clear নাকি না? Is that okay?
Yes, sir.
Yes, sir.
Parent classের জন্য তো ঠিক আছে, 0.3 is the misclassification error. Okay, so I'm going to clear it up as well. Now let's look at for the second situation. For the second situation, have a look here. Node n1, চিন্তা করি node n1. Node n1 এ কয়টা instances আছে altogether?
3টা.
3.
3টা. 3 belonging to class 1. So class 1 এ কয়টা আছে? 3টা। আর class 2 তে কয়টা আছে?
0.
0. Very good. আর node n2 তে? Node n2 তে কয়টা instances আছে altogether?
হ্যাঁ,
7.
বাসার নিচে
7 instances. So class 1 how many instances are there?
আচ্ছা
4.
ওকে তাহলে সাড়ে চারটা দিয়ে বলো।
Hello, can you guys
Yes.
mute? So there are 4 instances in class 1 and there are 3 instances in class 2. Is that okay, Nakina?
Yes, sir.
Make sense? Okay. Now let's find out what is the error for the first node N1. Tell me, what's the error in the node N1? 1
So
minus
0.
maximum. ভালো করে দেখি বলেন altogether কতগুলা instances আছে?
3টা.
3টা. So this is 3 out of 3. And this is 0 out of 3, right? Nakina, clear?
Yes, sir.
Yes.
Yes. So what is the error altogether?
0.
1 minus 3 out of 3. This is maximum. That is 1, which is what? 0. Clear? Yes.
Yes.
Sir.
Okay. And what about the error for the node N2? 1 minus maximum. What's the probability of the instances that belong to class 1? Altogether, there's 7 instances, right? So this is 4 by 7, and class 2, which is probability is 3 by 7. Is that okay, Nakina?
Yes,
Yes,
sir.
sir.
So what's the maximum here?
4 by 7.
1 minus 4 by 7, which is how much?
3 by 7.
3 by 7. Is that clear? Acha.
Yes, sir.
Now, what's the overall error, or what's the weighted error?
3 by 7.
Hey,
3 by 7.
wait. উল্টা পাল্টা কথা বললে হবে না, একটু ভালো করে দেখেন। Okay, how do you find the weighted error? Okay, let's figure this out. How many instances belong to class 1? Node N1? 3 instances. How many instances belong to class node N2?
7.
Node N2, right? 7. So overall, how many instances are there? Therefore, 10. তার মানে এটা হচ্ছে 10 এর মধ্যে 3টা এখানে, so 3 out of 10 multiplied by এটার এরর কত আসছে 0, রাইট নাকি না? ক্লিয়ার? প্লাস এটার ক্ষেত্রে ওইটার কি করব, এখানে 7টা আছে, so 7 out of 10, রাইট নাকি না? multiplied by এটার এরর কত
3 by 7.
3 by 7, correct? So how much is that? Now this is 0 plus, what about this? That's
3 by 10.
3 by 10. So how much is that? 3 by 10, which is 0.3. Is it clear, Nakina?
Yes,
Yes, sir.
So what's it? Yes? Yes?
Yes, sir.
Yes, sir.
So therefore, if you understand this one, now look at over here. How much is the error did you get for this one?
0.3.
What about the error for this one?
Same.
0.3.
And if I find that the error for this one, that would also come out to be 0.3. Okay? But I'm sure you can find it on your own now, right? Can you, Nakina? Using
Yes,
the
sir.
same strategy we've done. So
Yes, sir.
if you find out the error to be 0.3 here, sorry, just a minute. Error to be 0.3 here. If you find the error over here to be 0.3 as well, and if you find that the error over here to be 0.3 as well, now what do you think is the problem here now? The problem is যে এখানে এই এররটাকে কি হিসেবে ইউজ করছি? আমি using the error as a measure of entropy, তাই না নাকি না? Sorry, as a measure of impurity, তাই না? Is that right?
Yes, sir.
But if we get the errors to be the same, তাহলে measure of impurity কি পাচ্ছি?
Same.
Same. But if I'm using Gini as a measure of impurity, do I get them to be the same?
No, sir.
No. তাহলে using Gini, I do not find the measure of impurity to be the same, but I find the measure of impurity to be the same using error. Which one is more sensitive? Is it the Gini value or is it the misclassification error value? Which one is more sensitive?
Gini value.
Yeah.
Gini value.
Gini value is more sensitive, and therefore it can be used now in order to judge kunta level of impurity more or less and things like that. I can do that very easily, but that might not be done using misclassification error. ঠিক আছে? So because misclassification error value does not give a very high sensitive impurity value, ঠিক আছে? So that's the reason we usually do not use the misclassification error as a measure of impurity. It can be used as a measure of impurity, but it is not that sensitive. It's not a very good metric. ঠিক আছে? তাহলে for all practical purposes, what do we use as the measure of impurity? Gini or
Entropy.
entropy, but not
misclassification error.
misclassification error. Is that clear, Nakina? Yes. Okay. That's why we have written over here that the misclassification error for all these three classes, for this one, actually for all these three cases, not classes, for this one, and for this one, it's always 0.3. But if you're using Gini or if you're using entropy, you'll see they are not the same. They're going to be different because they're more sensitive, measure of, impurity. And that is the reason we typically use entropy or, or Gini to measure the impurity, the level of impurity. Is that clear, Nakina? Yes? ঠিক আছে? Are we good?
Yes, sir.
Yes, sir.
Okay. Now, decision tree has a number of advantages and a number of disadvantages. I think some of the very interesting advantage would be it's relatively inexpensive to construct. It's not. It is not very time consuming. It's actually relatively very inexpensive to construct. Number two is yes, sir.
স্যার আপনি কি প্লিজ স্যার তানজিনা একটা জুথির মাইকটা একটু মিউট করে দিবেন, উনি হয়তো ভুলে মাইকটা অন করেছে, প্রচুর নয়েজ আসছে।
Okay.
থ্যাংক ইউ স্যার।
Thank you.
All right. So here we are.
স্যার আমার কোশ্চেন ছিল স্যার।
Yes.
স্যার আমরা ম্যাক্সের মিসক্লাসিফিকেশন এররের যে ফর্মুলাটা দেখছি স্যার, অন মাইনাস ম্যাক্স ফাংশনটা, স্যার ওখানে স্যার আমরা অন মাইনাস ম্যাক্স ফাংশন স্যার মিসক্লাসিফিকেশন এররের যে ফর্মুলাটা ছিল অন মাইনাস ম্যাক্স ফাংশন ম্যাক্স, হ্যাঁ এখানে স্যার। সো এখানে স্যার অন মাইনাস ম্যাক্স না করে স্যার প্রতিবারই অ্যানসারটা কিন্তু স্যার মিন ভ্যালুটা আসতেছে, তো আমরা একবারে মিন ভ্যালুটা কেন ক্যালকুলেট করব?
না, that will not work. What you have said will work only if it's a binary classification. ঠিক আছে? কিন্তু আমার যদি বাইনারি ক্লাসেস না থেকে মোর দেন বাইনারি ক্লাসেস হয় তাহলে কিন্তু দিস মাইট নট বি দ্য কেস।
ওকে,
আমার কথা বুঝতে পারছো নাকি না? ওকে, সো এটা তুমি যেটা বলতে দ্যাট উইল ওয়ার্ক, আই আন্ডারস্ট্যান্ড হোয়াট ইউ হ্যাভ সেড। ঠিক আছে, এইখানে 0 পেয়েছি, ইজন্ট দিস দ্য সেম অ্যাজ দ্য মিনিমাম probability? ঠিক আছে, এখানে 1/6 পেয়েছি, isn't that the same as the minimum probability? এখানে 1/3 পাচ্ছি, isn't that the same as the minimum probability? Yes, that would have been true if it is binary classification. That means if there are only 2 classes. But if there are more than 2 classes, well, and you can have more than 2 classes, can't you? You can, right? Okay, in that case this will not work. Take a said the same thing will not work. Is that okay, Nakina?
Okay, got it.
Right, you got it right. Okay, good. Okay, now finally there are certain advantages and disadvantages for with this decision tree classification. One of the, I think, great advantage of decision tree classification is it is relatively very inexpensive to construct. Okay, it is as fast as classifying unknown records. Very easy to actually classify unknown records. Okay, it's easy to interpret. I think this is the most interesting thing for us. It's very easy to interpret for small size trees. For small size trees, like for example, when I say, let's take an example. Okay. Say, let's say this is what we're looking at. Okay. It's a small size tree. এবং এই ট্রিটা দেখে আমরা we can interpret what's happening. Okay, first we are looking at home ownership, then we are looking at marital status and income, so we can interpret. ঠিক আছে নাকি না? আমরা শুধু জানি না যে yes and no prediction, আমরা জানি যে also we know the with what rule, based on what rules is this being predicted. ঠিক আছে, so it's more interpretable. Okay, using decision tree. Clear, Nakina? Is that okay? So this is a great advantage. It's easy to interpret for small size trees. Okay, and there are other very interesting advantages. For example, it's robust to noise. Robust to noise would mean that if there are noises available, it would still be robust to noise. Okay, if there are some noises, well, it still knows how to actually tackle that. Okay, it can easily handle redundant attributes. Okay, if there are redundant attributes, redundant attributes মানে কি? Anyone?
So same attribute.
Same attribute or similar information আছে. For example, let's imagine you're measuring BMI index. I hope all of you know what's the BMI index, right? Yes. And
Yes,
let's
sir.
say you're measuring weight, and let's say you're measuring height. It turns out be BMI index, and let's say there are other parameters as well. Okay, it turns out to be that the BMI index depends on the weight and the height, right, Nakina? Okay, all right. So you don't give anything new here. Okay, so these are some redundant informations in a different form are provided. Okay, decision tree will be very capable of handling these redundant values. Okay, it knows how to handle that. So these are extremely this makes this particular classifier very interesting, very promising. Okay, all right. It can also easily handle irrelevant attributes. Okay, very irrelevant attributes যদি দিয়ে দাও, এমনও হতে পারে যে এই irrelevant attributes decision tree ইয়েতে আসবেই না. It doesn't even use that. It knows how to handle an irrelevant attribute as well. Okay. What are some of the disadvantages? Now, one of them would be that due to its greedy nature of the splitting criterion, interacting attributes, okay, that can distinguish between classes together but not individually, may be passed over in favor of other attributes that are less discriminating. Okay, we'll talk about this one, but that's a slight disadvantage here. And there's something called decision boundary. We'll talk about these things a bit later. Okay, but overall, decision tree classifier has a lot of very interesting advantages, which makes it more interesting. I think for us, the most interesting advantage that we have are that it is relatively inexpensive to construct. That means that's a great advantage. Okay, that it's not very time consuming. Number two, another interesting thing is it's easy to interpret. You can easily understand, okay, how a decision is reached. Yes or no, right? So that's a secondary very important thing that we can use with this particular classifier. And then also it has other advantages, like it's robust to noise. It knows how to tackle redundant attributes and irrelevant attributes. Okay, so this makes this classifier extremely powerful. Are we good so far, Nakina? Is that clear?
Yes, sir.
Okay, so how much time do we have? We have something like 15 minutes time, right, Nakina? Okay.
Yes.
So I'm going to very quickly demonstrate you how you can use this decision tree classifier in Weka first of all, and then maybe I can show you a little bit how can you use it in scikit-learn. But if you don't use it in scikit-learn today, that's fine, because next week what we're gonna do is we're gonna eventually start a step back, start looking into how to do small programming using Python. We're going to learn about how to use other libraries like matplotlib to plot different graphs and stuff like that. Okay, and also we're going to start talking about how can you use scikit-learn to do different kinds of things. So we're going to dedicate the next week to hands-on programming. Okay, so don't be late in the next class, because otherwise you'll start from the middle, right, Nakina? Okay, so I'm going to Weka start করে দেখাই আপনাদেরকে. Weka is very simple tool. So I'm going to just show you very quickly here. So if I open up Weka, okay, go to the Explorer tab. Okay, and after we go to the Explorer tab, first of all, you need a file. So I'm just going to use an existing file in order to just show you how you can actually use the Weka to do different things. So go to Weka. going to go to data sets. I'm going to use an existing library. Let's say I'm going here, whether, no, sorry, I don't want to use that. Let's open up again. I want to use this one. Oh, come on. Okay, that's it. So we have certain things here. We have got a few attributes like outlook, temperature, humidity, windy, and we want to predict whether John is going to play tennis or golf that day or not. So we spoke about this data set before. There are altogether, as you can see, there are 14 instances. If you want to see what these 14 instances are, you can press edit. You don't have to edit, but you can look at what these instances are here. Right? Is that clear, Nakina? Yes? Are we good?
Yes.
Okay. So then if you go to the next tab, which is the classify tab, you can now choose which classifier you want to use. And there are a number of classifiers here. Now, decision tree comes out to be based on a tree classifier. So I'm just going to minimize that. Let's expand these trees. So there are a number of tree classifiers. And one of the classifiers that we have there, as I said, if you remember, there are different kinds of decision trees as well. One of the decision trees that we have is called the J48 classifier. So I've clicked on the J48. If you want to know different parameters of that, you can click on this and see the different parameters are there. If you want to know about the capabilities and stuff and more about them, you can just click on them and read this documentation about what these things are, right? Okay, so that's what you can do. Okay, you can see what their capabilities are, so you can do that as well. Okay, right. So, and these are the different things that you gonna use, right? Okay, all right. So anyway, I'm not going to go into that. I'm going to just simply use the training set, that those 14 instances, and I'll just train them. So that's it. Training is done. So we have done the training. So now this is the model that's created. So I can right click on that. And there's something called over here, visualize tree. And if I click on that, that's the decision tree that's generated. Is that okay, Nakina? Yes?
Yes, sir.
Yes, sir.
Okay. Now, you know, there are certain details I didn't mention here. Why don't we use, what is this using training test? So we use all the 14 instances as a training set. Okay. So we did not supply a different test set to check. So this is the training accuracy, therefore. Okay. And what's this called, percentage split and other things. So we didn't talk about those things. Those are things we're going to discuss later. Okay. Is that okay, Nakina? All right. Is
Yes,
that
sir.
fine? Okay. But you at least know how to use this tree to see different things. Take a second. Okay. How to at least create this decision tree using the wake up. Right. So next class I'm right to carefully they go, because next week what I want to do is, we don't want to discuss any more classifiers in the next week. Next week, duto class আছে আমাদের. Duto class we would like to dedicate 2 classes on different aspects of machine learning, different practical aspects of machine learning, and how to program them. Okay. Right. So I guess what I'm going to do is, we still have 10 minutes time. I'm going to very quickly give you an overview. Kintu amra next class e etake details discuss kori on how to actually, you know, program using a scikit-learn. ঠিক আছে? Program, you know, একটা decision tree বের করতে পারি using a scikit-learn. এটা next class এ করি, but let's actually show you very quickly what we can do. ঠিক আছে? দেখাবো একটু। But next class আমরা একটু time দিয়ে more carefully ওগুলো আমরা করব। ঠিক আছে? Okay. But এখন just একটা overview দিয়ে দিই very quickly so that you are aware. So I'm going to start up something called Jupyter Notebook. Right. So there's something called Jupyter Notebook. এটা আমরা next class এ দেখাবো। এখানে here's a code. This is something we will discuss it in the next class. Don't worry about it. Okay. আমি এখন just very quickly দেখাচ্ছি যে কি করা যায়। ঠিক আছে? Okay. So Jupyter Notebook, আপনারা last time মনে আমি কিসে কোড করেছিলাম? Which editor did I use? Does anyone remember? Spider, right? Acha. Now this time I'm writing in a Jupyter Notebook. The advantage of Jupyter Notebook is each cell can be actually, you know, run on its own. তোমার পুরো কোডটাকে রান করতে হবে না, একটা কোড রান করতে পারো। So for example, I want to see PWD means right now what is the working directory, ঠিক আছে, print working directory, okay. Right now I'm at C users source এটাতে এখানে আছে, ঠিক আছে। Then the second one is I'm importing pandas as pd, so okay, let's just run it. So, okay, run করলো, pandas import হলো। Now then we are reading a CSV file. We'll talk about this file vgsales.csv, okay, sales area run করলো। So we read a CSV file and the file is available in this location. And if I click on df.shape, it tells me the shape of that data frame. Okay, what's the size of this one? I know there are 16,598 rows and there are 11 columns. Okay, and if I click on this df.describe, all right, we'll run that df.describe, and it gives like for each of these 11 columns, okay, like rank, year, and all these things. Okay. What are the count values, mean value, for lower quartile, median, upper quartile, maximum value? It's a description there, ঠিক আছে। And if I give df.head, df.head then কি করে মনে আছে?
স্যার প্রথম 5টা ডেটা প্রিন্ট করে,
প্রথম 5টা instances শুধু print out করে দেখে। So you can just have a look at what these instances are, ঠিক আছে। Okay, this is simply df.describe করে describe এর থেকে mean ভ্যালুটা শুধু জানতে চাই, তো প্রত্যেকটা ইয়ার mean ভ্যালু জানতে চাই, I can do that. Okay, আচ্ছা, এটা তো fine, you can print hello world. This is how you print hello world. It's just small codes. We're gonna see these things in the next class, don't worry. Okay, আচ্ছা, right. Okay, next one is, let's have a look here. এটা একটা মজা, এই ডেটা সেট নিয়ে আমরা নেক্সট ক্লাসে কাজ করব। So একটু বলি data set দেখেন, we have got 5 minutes or 6 minutes, so let's see this one. So we're running this data set. The data set is in this location. Okay, it's called music.csv data file. I think I already uploaded this data file. Maybe you can have a look in the Google Classroom. Okay, and so we read that CSV file and we put that data in a data frame called music data. So when I said music data, what did it output? It created what we have in this data set. A data set is কি আছে দেখেন তো? Anyone? What do we have in this data set?
So,
Age,
music
gender, or what kind of genre does that particular person like? For example, if the age is 20, gender 1 মানে হচ্ছে এখানে হচ্ছে I guess male, ঠিক আছে। So a 20 years old male, he likes hip hop. The 23 years old male, he likes hip hop music, ঠিক আছে। 25 years old male, he likes hip hop. 26 years old male, he likes jazz, and we have a little bit of data over here, right? নাকি না, খুব বেশি না, small data, right? নাকি না, clear? It's like 21-year-old female, she likes dance, ঠিক আছে, dance music. 26-year-old female, she likes acoustic music, and so on. So it's a very small toy data set. It actually, it's available now, it's just we made it up, that's all. Okay, it's a made up data set. Now তাহলে এখান থেকে যদি আমি classifier use করতে চাই to classify, so which are x and which are y? Can anyone say? x কোনগুলো, y কোনটা?
জেন্ডার আর এজ হচ্ছে
Age and gender is x, right? নাকি না, right?
yes
Yeah.
sir.
And why, the thing that we want to predict is the genre. Clear নাকি না? Is that right?
Yes.
Yes sir.
Yeah. So the first thing that I do over here is আমি এই মিউজিক ডেটা তিনটা আছে, এজ, জেন্ডার অ্যান্ড জনরে। এই মিউজিক ডেটা থেকে আমি ড্রপ করছি কোনটাকে? জনরেকে বাদ দিয়ে দিলাম, তাহলে এজ এন্ড জেন্ডারই থাকলো, রাইট নাকি না? ক্লিয়ার? ইয়েস
Yes, sir.
ইয়েস নাকি না?
Yes, sir.
আর ওয়াইটা হচ্ছে এই মিউজিক ডেটা থেকে শুধু জনরেটা নিলাম, ঠিক আছে। সো ইফ ইউ ডু দ্যাট, সো ইফ লেটস রান দিস, লেটস রান দ্যাট, and then আমি x কে যদি রান করি, so see x actually has just age and gender, so this is my x and this is my y. So if we run this one, that's the y, this is the output. So আমি x and y কে ভাগ করে দিলাম, ঠিক আছে। x টা হচ্ছে আমার features আর y টা হচ্ছে আমার target that we want to predict. Is that okay নাকি না? Clear?
Yes, sir.
Acha, now let's come over here. Okay. Now this is where we are doing very interesting stuff. So I've imported a number of things. I mean, just quickly bole dei, but in the next class we're gonna see in a little bit more details. Okay. From scikit-learn.tree, from sklearn.tree, what did we import? Decision tree classifier, because we're gonna use the decision tree classifier to create a model, right? Nakina. So we import decision tree classifier. ঠিক আছে এটুক নাকি না? Clear?
Yes, sir.
Yes.
Yes,
Hello. Okay.
Yes, yes, sir.
Can you hear, guys? Okay.
Yes, sir.
Then we are importing another interesting thing, which is sklearn.model.selection থেকে model selection থেকে we're importing something called train test split. Now, মনে আছে in the last class যখন আমরা last class মানে হচ্ছে a few classes back, when we were discussing, how to, okay, zero classify যখন implement করছিলাম, আমরা একটা there was something that we did which we shouldn't have done, but we say that we shouldn't have done, but that we just did it, right? Okay.
Yes,
What
sir.
was
Yes,
that?
sir.
কি করেছিলাম,
আমরা
যেটা ট্রেনিং ডেটা সেট ছিল সেটার উপরেই টেস্টিং করেছি, রাইট নাকি না? রাইট?
Yes,
Yes
sir.
নাকি না?
Yes,
মনে আছে?
yes.
But that's what we do not want to do. We want to have a separate training set and test set. So training সেটের উপর ট্রেন করব আর টেস্ট সেট দিয়ে ইভ্যালুয়েট করব, টেস্ট করে দেখব কেমন কাজ করছে না, রাইট নাকি না? Is that clear? Yes? Okay.
Yes, sir.
So এইটা হচ্ছে ট্রেন টেস্ট স্প্লিট। এই পার্টিকুলার জিনিসটা দিয়ে আই এম গোইং টু ভেরি ইজিলি split my data set into training set and test set. You'll see that, okay? Then we import something called accuracy score. We discussed about that. So that will measure the accuracy. And there is something called sklearn.externals থেকে import job lib. Now, what is a job lib? Don't worry about it now, because I'm going to show you in the next class what does a job lib do. It does something very important. So I don't want to go into this right now, because I just have about 2 minutes to give you an overview, but we'll discuss these things in more details. What does this job lib do? Okay. Now look at this one. Look at this simple code. Train test split. I'm calling this train test split. And then এখানে X হচ্ছে আমার কি? What are my X? Features. What is
Age
Y?
and gender.
Target বা ঠিক আছে?
Genre, sir.
আর আমার টেস্ট সাইজ কত দিয়েছি?
20%.
Zero.
0.2.
Right. তার মানে I'm
20%.
dividing my data set into how many parts? I'm dividing my data set into 2 parts, training set and test set. Training set কতগুলা? 80% data আর training set, and 20% আছে test set. Clear নাকি না? Yes?
Yes, sir.
Yes. এবং করবার পর দেখেন এখানে কি, this is equal to, it has been assigned x train, x test, y train, y test. এইভাবে লিখতে হবে। তার মানে ট্রেনিং সেটের x ভ্যালুস গুলো এখানে থাকবে, ট্রেনিং সেটের টেস্টিং সেটের x ভ্যালু গুলো এখানে থাকবে, ট্রেনিং সেটের y ভ্যালু গুলো এখানে থাকবে, টেস্টিং সেটের y ভ্যালু গুলো এখানে থাকবে। ক্লিয়ার নাকি না? Yes? And you don't need to worry anything else. This train test split command, this one line command would do that. You don't have to do anything else. Is that okay নাকি না? Okay. Now,
Okay, sir.
what kind of classifier you're using? You're using something called a decision tree classifier. So this is a decision tree classifier. And so that's the model that we're selecting. So how do we train? We train using the fit command. Remember that? Zero classifier দেখাচ্ছিলাম, fit command use করে আমরা করি. So model.fit. So I'm using the decision tree classifier to fit. And what's the training set that on which we are fitting? Now see, we are not using the entire data set. We are using the training set. So because we are using the training set x value গুলো দিয়ে দিচ্ছি feature, এবং training set y value গুলো দিচ্ছি. I didn't give the test set, so I didn't test it on the test set. Is that okay নাকি না?
Yes, sir.
Okay. I'm going to মানে avoid these codes right now, because এই কোড গুলা কি করে, job lib এর কাজ কি, I'm going to show you later on. ঠিক আছে? And then there's something I do is I'm going to use something called tree. What is that tree? এই যে import tree না, এই ট্রিটা করে এই যে ট্রি ডায়াগ্রামটা কেমন চেহারা ওটাকে ভিজুয়ালাইজ করার জন্য, ঠিক আছে? So then we do something called export graph viz. এটা একটা সফটওয়্যার দিয়ে তোমার দেখতে হবে, and I've written a few configuration here. Don't worry about this right now. I'm going to talk about this. But what it's going to do really, it's going to create, now if I run this one, let's run this one. If I run this one, it's going to create a file, ঠিক আছে, in the directory called music.recommender.dot. So if I show you, I was in C users ASUS ছিলাম, right? and if you go over here, you see over here it creates something called music recommended dot একটা dot file তৈরি করে. Now if we look at that dot file, so I'll look at this one, so I'm opening it one using Open Office Writer. You can use Microsoft Office Word, but just because I do not use Microsoft Office Word, so I'm using with a different software. So if I go over there, see, okay, I'm right over there. If I go to this music recommended dot, okay, whatever, I don't care. So it gives you a weird looking code. Okay, so that's this one. So I just copy this one. Okay, and there's something called GraphViz. So okay, so you need to have GraphViz installed. Okay, so I'm going to write down GraphViz. Okay, I'll just write down this GraphViz right now. It's a graph visualization software. If you have this visualization software installed in your machine, you can use that to see the graph. But I couldn't be bothered to see that, so I can use it online. GraphViz online, so I can go there, and here's the code. Here's the corresponding graph. So I'm just copy করেছি আমার কোডটা. If I paste that code, don't worry about that. Wait a little bit, and this is the decision tree that it created. Is that okay, Nakina?
Yes, sir.
That's how it works. ঠিক আছে? So it basically created a decision tree. আমাকে বলতে পারবা এখানে decision tree তে which what measure of impurity has been used?
So Guinea.
Guinea. You can see that, right? Guinea value দেওয়া আছে, তাই না? এখানে
Yes, sir.
14টা স্যাম্পল ছিল, আস্তে আস্তে তোমার 10টা 4টা ভাগ হতে ইউনিক পেয়ে গেছি আমরা, রাইট না কেন? Okay. Now in your scikit-learn, the default criterion that we use to split is the Gini index. But তোমরা যদি কেউ বলো আমি Gini দিয়ে করব না, আমি entropy use করতে চাই, no problem. Look at the scikit-learn documentation for that. So I can just write down over here if we want to use this one. So I can say scikit-learn pre-classifier. Okay. So you go to the documentation, just go there. And if you go to the documentation, you'll see যখন decision tree classifier use করছি, আমার কোডের decision tree এখানে আমি আরো কথা বলবো, don't worry about it. But let's see over here. আমরা যখন decision tree classifier use করছি, কোথায় use করেছি? Decision tree classifier এখানে, right? এই যে I invoke the decision tree classifier. Now it's written over here. If you go over here, you'll see where are we here? Now, when we go to the decision tree classifier, if you look at the parameters, there's a lot of parameters here, but we are not looking into those. But here's a parameter called criterion. Criterion parameter কয়টা value নেয় বলুন তো? দুইটা parameter. But আমি কিন্তু কোনো criterion নেই, কারণ হচ্ছে my default criterion is what in scikit-learn? Gini, right? But if I want to entropy, all I need to do is nothing, but I could go over here. I would write the parameter. So I can write criterion equals to, I could now write, what was that? Entropy, right? Nakina, clear? So I can just write entropy and we're done, okay? Now, file new. Okay, let's go text document. So what I'm going to do is, I'm going to close this one. Okay, let's keep that open. Okay, so I'm now saying this is entropy. So if I run this one, okay, I've run this code. So if I run this code, a music recommender, and now I will have the one for entropy, right? So now if I go open, I can click on recent document because I just, okay, that's okay. Now I'll just simply copy that code over here in GraphViz Online, Control A, paste that one and wait. Okay. And now could you see, now it created a decision tree with what criterion?
Entropy.
Entropy. Very good. You just have done it with entropy now. Is that clear? These are easy codes. We're going to see more about these things, how to do all these things in the next class. But next week, sir, what we are going to do? We are going to concentrate on Python and other other libraries, how do you use other libraries to do some very nice clean job, so that next week পরে আপনাদের Python scikit-learn এগুলাতে আপনাদের আর কোনো সমস্যা যেন না হয়। নেক্সট উইকের পরে whenever you need to do something, you will learn how to use the documentation and to do something on your own. So next week পর you're fine with using this scikit-learn and things like that. এরপর দেখবেন আপনাদের কাজ করবা কোড করবা খুব ইজি হয়ে যাবে সবকিছু, ঠিক আছে? Is that clear নাকি না? Yes.
Yes, sir.
Yes, sir.
Yes, sir.
So we'll see those things in the next class. Good. Okay. So
Okay,
I know
sir.
I'm running out of time. If anyone has a question, let me know right now. If you have 1 minute question or things like that, or we're done. আর আরেকটা জিনিস হচ্ছে আপনাদেরকে একটা বইয়ের নাম বলেছি, right? Hands on machine learning with scikit-learn, Keras and TensorFlow, right? Okay. If you can grab that book, ঠিক আছে? If you don't have, the hard copy, if you get the PDF version, please have that. কারণ বইটা খুবই ভালো। তুমি দেখবে যে তোমরা যে এরপর যে নেক্সট উইকে কোড টোড করবার পর টুকিটাকি জিনিস দেখতে হবে। This is a good reference book. ঠিক আছে? Okay, right? Okay, it will be a very good handy book. ঠিক আছে? Okay. So does anyone have any questions? If not, I'll stop the recording. Okay, I assume that nobody has any questions. I'll stop.